Question 5c. Consider the function f of x equals 2 times inverse sine of the square root of x minus the inverse sine of 2x minus 1 for x greater than or equal to 0 and less than or equal to 1. Part 1. Show that f dash of x equals 0 for x greater than 0 and less than 1. Before differentiating f of x, we need to write f of x using powers rather than surds. So f of x is equal to 2 times inverse sine of x to the power of half minus inverse sine of 2x minus 1. Now recall that d dx of inverse sine of f of x by the chain rule is equal to f dash of x over the square root of 1 minus f of x all squared. So to find f dash of x, so the derivative of this function here, I'm going to differentiate this term, subtract one from the other, and hope that it equals 0. So d dx of 2 times inverse sine of x to the power of half, this is our f of x, is equal to f dash of x times 2. Now this times 2 comes from this 2 here. So that's equal to half times x to the power of negative half times 2. Now this half and this times 2 will cancel, over the square root of 1 minus x to the power of half squared. And that simplifies to 1 over the square root of x times the square root of 1 minus x. We'll call that number 1. Now the derivative of inverse sine of 2x minus 1, again by the chain rule, is equal to 2 over the square root of 1 minus 2x minus 1 squared. So we have a perfect square here, which we will need to expand shortly. We'll call that number 2. So to find f dash of x, we'll take number 1 and subtract from that number 2. So f dash of x is equal to 1 over the square root of x minus x squared minus 2 over the square root of 1 minus 4x squared minus 4x plus 1. So I've expanded this 2x minus 1 squared, and this is our perfect square expansion. Now this 1 and this 1 here will cancel since we have 1 minus positive 1. So f dash of x is equal to 1 over the square root of x minus x squared minus 2 over the square root of 4x minus 4x squared. So the next step is to factorize out the 4 and take it outside of the surd, so that becomes 2. So that equals 1 over the square root of x minus x squared minus 2 over 2 times the square root of x minus x squared. So the numerator here of 2 will cancel with this 2 here in the denominator. So we have f dash of x is equal to 1 over the square root of x minus x squared minus 1 over the square root of x minus x squared, which equals 0 as required. Part 2. Sketch the graph of y equals f of x. From part 1, f dash of x equals 0 for x greater than 0 and less than 1, which means the graph of y equals f of x will be a horizontal line, since a horizontal line has a gradient of 0, with equation y equals c, where c is the constant, for x greater than or equal to 0 and less than or equal to 1. To find the value of c, choose a value for x in the domain and find f of x. So I'm going to choose a value halfway between 0 and 1. So I'm going to choose x equals half. So f of half is equal to 2 times inverse sine of 1 over the square root of 2 minus inverse sine of 2 times half minus 1. And that equals pi over 2. So the graph will look something like this. It should be a horizontal line from x equals 0 to x equals 1 with a height or a y value of pi over 2. The following is the feedback from the Marking Centre for Question 5c, Part 1. Candidates were required to show that the derivative of a function involving inverse trigonometric expressions equals 0. Although many candidates understood how to differentiate inverse sine, they often showed little understanding of differentiating the function of a function. In this case, candidates were usually unable to gain any marks. The first 2 marks were gained for correct evaluation of each inverse trigonometric expression in the function. The final mark was allocated to showing that the derivative equals 0. Many candidates undertook time-wasting pages of algebra trying to show this, although to little avail when their differentiation was incorrect. Other candidates fudged their algebra. It is essential in a show that question not to make too many leaps in the algebra, but to write down clear and logical solutions. For part 2, candidates were required to graph the function given in part 1. Many candidates successfully did so, although they were unable to show that the derivative equals 0 in part 1. It was essential to graph the function correctly over the given domain to gain the 2 marks. Some candidates attempted to graph the function by subtracting ordinates, not realizing the significance of the gradient being 0. Although their approach was quite sophisticated, they missed the point of the entire question. Candidates need to be reminded to look for the linkages between different parts of the question.